Today we're going to complete the notes for confidence intervals with proportions. Two things that must be true about proportions is that the samples must be random. Also, the conditions for the binomial experiment, meaning it has only two possible responses, is satisfied. Many times the rounding rule comes into play here, and since we usually do two decimal places when we change a percent to a decimal, we're going to round our answers to 3 decimal places. We're going to assume that we're following the standard procedure for changing percents to decimals and decimals to percents. As we continue to work our way through this, please keep in mind that you're looking for percentages, that P has to be given as a percent. Well, what is P? P is the number of yeses over the total number. Many books write this as X over N. Now for us, when we're doing our project, we're deciding what our yes is, and then we're taking that number and dividing by the total. That's what we did in the Google Sheets to find P. Also remember that Q hat is 1 minus P hat, or 1 minus P. That formula has not changed, and you will be able to use that as well. E is your error. That is your Z sub alpha over 2. And in this case, we're going to use the square root of P hat times Q hat over N. Now, you'll ask, what is the difference between P hat and P? Nothing. A lot of it has to do with how books were printed, the notations that were used. So you will see P hat, you also may just see P. So for our formula, we're going to have P hat. Since we don't have an average, we're going to use our P hat plus the Z sub alpha over 2 to the square root of P hat times Q hat divided by N. Now, one of the things you're going to have to be careful with in the calculator is you're going to have to remember to put a parentheses around this part, and remember that the calculator automatically gives you a parentheses, so you're going to have to close that one down. So be very careful if you're putting these into the calculator. We're going to do a couple of examples now, and you'll need to fill these in on your notes as well. Example 7-9, a survey conducted by Sallie Mae and Gallup of 1,404 respondents, so that's my N, found that 323 students paid for their education using student loans. So 323 is my X. Find the 90% confidence interval. So remember, for 90%, we have those 3 numbers that we're supposed to remember, and the number for 90% is 1.65. So we need the 90% confidence interval of those who paid for their education using student loans. So let's make sure we remember how to do this. P hat is X over N, so that would be 323 over 1404. Now, when I put that in the calculator, you should get 0.23. or 23%. Then Q hat is gonna be 1 minus 0.23, which is gonna give me 0.77. Just as a reminder, the numbers that you're supposed to remember for the z of alpha over 2, 90% is 1.65, 95% is 1.96, 99% is 2.58. Okay, so let's fill in the formula. We have p hat plus or minus z of alpha over 2 to the square root of p hat times q hat over e. Remember, we're going to take care of our parentheses. So 0.23 plus or minus 1.65 to the square root of 0.23 times 0.77 divided by n, which was 1,404. When you put that in the calculator, take the time to go through and put it in the calculator. That's 0.212 for the minus side and 0.249 on the other side. So it asked me for the confidence interval. It did not say I had to do a percentage, but if I were to do a percentage and move this over 2 places, that would be 21.2% to 24.9%. So basically, you're just replacing a couple of things. You don't have the standard deviation, so you're going to have to do this. That's also one of the keys. If you don't have a standard deviation, you're going to have to use p-value. So keep that in mind as you go through and as you start looking at different kinds of problems. So let's look at example 7-10. I have a survey of 1,721 people found that 15.9% of individuals purchase religious books at a Christian bookstore. Now that is my P because it's the percentage. So I need to turn that into a decimal first, so that's 0.159, and I want a 95% confidence interval. So remember the number for 95% is 1.96. I need to find Q, which is 1 minus 0.159, which is 0.841. Filling in my formula again. Remember, you have to do both sides, both the plus and the minus. Don't forget about that. And as we fill it in, we have 0.159 plus or minus 1.96 to the square root of 1.59 0.159 times 0.841 divided by 1721. When you put that in the calculator, it's going to be 0.142 for the minus side and 0.176 for the plus side. So that's 14.2% to 17.6%. Now some of you are looking at this notation and saying, do I have to write it like that? No, you can also write it like this. Whichever way is easier. A lot of people confuse this with a minus sign, so I tend not to write it that way, just so that you know it's between those two numbers. Okay? All right. As we go on through, we're going to look at what happens if I am asked to do the number of things that we actually need for the sample. Okay, as we go through this, we're gonna look at that. We will spend some time with that tomorrow, and actually go through examples 7-11 and 7-12 tomorrow. So as you go through and work your problems, make sure that you fill in your notes. The first part should be filled in, and we will turn those in tomorrow, or you will show those to me tomorrow after we fill in the last couple of problems. So you'll be doing some p-value problems today. You also need to fill in your t distribution notes as well.